Hello friends, welcome to Sidza.com. Now in this video we will do some of the numericals on the limiting reagent. But before, I would suggest to all those people who have not seen my previous video in which I have defined what the limiting reagent is and how to find the limiting reagent, I strongly suggest to you people to first see that video, to see my previous video, and then come back to this second video on the limiting reagent. So here we have certain reactions, and we need to find the limiting reagent and the excess reagent from the following reactions. In our last video, I have told you that to find the limiting reagent, we compare the ratios. We compare the experimental ratios here. This is an experimental ratio with the balanced equation ratio. So the balanced equation ratio here is A by B. The balanced equation ratio is 7/6, right? Which is equal to 1.166. And experimental ratio here is, the experimental ratio over here is 21 moles of A reacted with the 24 moles of B. And the ratio here is 0.875. Now we look at this ratio. The experimental ratio is less than the balanced equation ratio. So it is less, that means the A is a limiting reagent. Okay? And B will be the excess reagent here. If the ratio is more than the balanced equation ratio, suppose rather than 0.875, if it is 1.266 or it is 1.200, anything more than 1.666, anything more than the balanced equation ratio. If the ratio here, experimental ratio, is more than this, more than the balanced equation ratio, then it means the B will be then the limiting reagent. So from the second equation, we look at here, A and the B, they react in the ratio of A by B ratio. Here is 2/3. This is the balanced equation ratio. Okay, the balanced equation ratio is 2/3, which is equal to 0.666. And the experimental ratio here is, when you mix A and the B, you mix the 20 moles of A with the 25 moles of B. So the limiting reagent here will be 20/25. The ratio is 0.8. That means the experimental ratio is more than the balanced equation ratio. It's more, that means A is more and the B will be the limiting reagent, right? So here B is limiting reagent and A is excess reagent. And now in the third equation, we got the balanced equation ratio between the A and the B, that is 10/7, which is 1.428, right? 1.428. The experimental ratio here is between the A and the B. The experimental ratio is 30/21, which equals 1.4285. So here is also 1.4285, and the ratio, what we find here is the same, right? It is the same. There's no change. That means in this equation we don't have any excess reagent or the limiting reagent. The reactants are in the exact ratio in which they react. So at the end of a reaction here, in the third case, you will get the products C and the D only. You will not find any of the excess reagent here. Fine. Now let's do some questions on the limiting reagents. Here we have a reaction between the nitrogen and the hydrogen gas to produce the ammonia, and it says 5 grams of nitrogen reacted with the 10 grams of hydrogen to produce ammonia. Calculate the ammonia formed, the amount of ammonia formed, and we have to find the limiting reagent here. So let's write down first of all the balanced equation. The equation is nitrogen reacts with the hydrogen gas and forms ammonia. When you balance it, it is twice ammonia and this is 3 times hydrogen. Now this is the balanced equation ratio. And from the balanced equation ratio, we find that the ratio between the nitrogen and the hydrogen is 1:3. And you get how much of ammonia? You get 2 moles, right? So this is the molar ratio here. This is the molar ratio. 1 mole of nitrogen reacts with 3 moles of hydrogen to get 2 moles of ammonia. Now there are two ways. Either I will change here the weight of the nitrogen and the hydrogen in moles, or I will convert from the balanced equation ratio, the molar ratio, into this weight ratio, and then compare the two. Either I can compare the weight ratios or the molar ratio. So let me take here the weight ratios in both cases, right? So I'll convert the molar ratio from the balanced equation into the weight ratio, right? So therefore the weight ratio here will be 1 mole of a nitrogen means how much? 28 grams of nitrogen, and 3 moles of hydrogen means 6 grams of hydrogen, right? And 2 moles of ammonia means 2 times 17, so this is 34 grams of ammonia. This is the weight ratio. Okay, this is the balanced equation weight ratio. This is the molar ratio. Now our experimental ratio is, we react to the nitrogen 5 grams with hydrogen how much? 10 grams. I need to find out the amount of of the product formed. So first I'll check the limiting reagent. The weight ratio from the balanced equation is, nitrogen by hydrogen weight ratio is, it is 28 by 6, right? So 28 grams of nitrogen reacts with the 6 grams of hydrogen, and the ratio is 4.666. The experimental ratio here is nitrogen hydrogen. The experimental ratio is 5 by 10. It is 0.5. It's very less than this one, right? Isn't it? It's less than the balanced equation ratio. That means it's less. It means that the nitrogen is the limiting reagent and the hydrogen is the access reagent, right? So nitrogen is the limiting reagent and hydrogen is the access reagent, and the amount of the product formed depends on the limiting reagent. So I will relate the product with the limiting reagent. From the balanced equation, we get 28 grams of nitrogen produces 34 grams of ammonia, right? I'll check for the 1 gram how much I get. From 1 gram of nitrogen we get 34 by 28 grams of ammonia. And my limiting reagent here is nitrogen, which is equal to 5 grams. So therefore, for the 5 grams, from 5 grams of nitrogen you will get 34 by 28 times 5 grams of ammonia, which is 6.071 grams of ammonia. Okay, this is the weight of ammonia that will be formed here. Fine, so let's take another example. Here is the reaction between the carbon and the oxygen to produce carbon dioxide. We have to identify the limiting reagent and the amount of the carbon dioxide formed. So first of all, we will react the carbon. I'll write down the balanced equation first. Carbon reacts with oxygen and forms carbon dioxide. And this is the balanced equation. We don't need to do anything else, right? And the balanced equation says 1 mole of a carbon reacts with the 1 mole of oxygen and you get 1 mole of carbon dioxide. So this is the molar ratio here, right? This is the balanced equation, molar ratio. So therefore the ratio between the carbon and the oxygen here is 1.0, 1 by 1, it is 1. And in our experiment we mixed 3 moles of carbon with 2 moles of oxygen, right? So in our experimental ratio, what is our experimental ratio? It is 3 moles of carbon react with the 2 moles of oxygen, right? So we need to check the weight of carbon dioxide produced. So first I will check the limiting reagent. So the ratio here between the carbon and the oxygen is, the experimental ratio is 3/2, right? It is 1.5. And this 1.5 is greater than the balanced equation ratio, right? It is more than this one, which means that carbon is more and the oxygen is less, right? That means oxygen is the limiting reagent, right? And oxygen and the carbon will be the, carbon is the access reagent here. Okay, so the limiting reagent is oxygen, and I'll relate the limiting reagent with the product from the balanced equation. And from the balanced equation I say that 1 mole of a carbon, 1 mole of oxygen produces 1 mole of carbon dioxide, and my limiting reagent is oxygen, which is 2 moles. So I need to check it for the 2 moles. Therefore, for 2 moles of oxygen, you will get 2 moles of carbon dioxide. And now let's see the access reagent carbon, how much of the carbon is left at the end of a reaction. So again, that I will relate with the limiting reagent, right? So from the balanced equation, we find that 1 mole of oxygen reacts with 1 mole of a carbon, and therefore 2 moles of oxygen will react with only the 2 moles of carbon. Out of the 3 moles, amount of carbon left will be 3 minus 2, that is 1 mole. So at the end of a reaction, 1 mole of the carbon will remain unreacted. So in the reaction mixture, what you will find at the end of the reaction? In the reaction mixture, you will get only 2 moles of carbon dioxide and 1 mole of a carbon, because carbon was the access reagent and all of the oxygen was consumed. Hope you got the concept. Thanks for watching the video. Bye for now.